Yeah, so the review question, what is the name of the tool shown to the right? It's a little ridiculous, but some people will call it a compass.
I almost did.
Yeah. So what is it?
It's a protractor.
Protractor. Then you are to draw a line segment to classify each angle measure, then draw and label the angles on the tool. So I would suggest you use different colors if you have them. So 90 degrees, that's a toughie, is a right angle. Agreed? So I can't use a ruler, but you need to use the straight edge of your protractor to draw a straight line through 90 degrees to the circle there. And then from here to here is 90 degrees.
I thought you were going to say to draw straight out from 90 to right.
And then I'm going to switch colors for the 25 degrees. 25 degrees is what kind of an angle? Acute or obtuse? Acute. And so here's your 25 degrees right, see if I can get it, there. Bless you. So we're going to go from here using a straight edge. Obviously I didn't, because I can't on my notes. I haven't figured out that ability yet. I'm not sure if I even have that ability. And so from here to here is 25 degrees. And so this is 25 degrees out here. And then our last angle, 155, by process of elimination, is obtuse. It's greater than 90 degrees. And so you're looking at the inside, because we're going from this being 0 degrees. The inside is what you're looking at for the 155. If you're doing the outside of the circle, that means that your angle is opening from here and going in that direction. So we want the 155 that's down here, so we're going to mark that point there. Wow, that's really super teeny weeny tiny. So there's the 155. So from here to here is the 155 degrees. And that's going to be important in a minute. Okay? So then let's look at your vocab. So we're going to look at rotation today. So a rotation is a transformation which turns, that's the terminology you're not allowed to use with it, it turns a figure about a fixed point called the center of rotation. So reflections were over a line, rotations are about a point. And so look at 3. Sometimes, and for some of you, spatially this is difficult. It's easier if you're looking at a colored picture than if you're looking at the black and white picture in front of you. So look at the color up here. Let me just set it right there. Is this figure from here to here a rotation? Yes or no? So this would be the point at which it's rotating. And the whatever you call these things, the arms of the windmill, I guess. Blades, thank you. That's what I was really looking for. The blades of the windmill are not equal distance apart, are they? So my suggestion would be that you pick, an obvious distance, like this right here would be the same as this right here. And so, or this one, that might be the easiest since it's the one that's the smallest of the two, right? So there's a couple of ways to look at this. It's either rotating counterclockwise or it's rotating clockwise. You'll see in this book that they go counterclockwise. So the rotation went, let me choose green since it's a different color from there. Rotation went from here all the way up to here. So this line right here is the same as this line right there. So that is a rotation. And how much, it's probably, from here to here is probably, I don't know, and I'm only guessing, probably about 45 degrees. So it'd be whatever 360 is minus 45 degrees. And that would be your degree of rotation. So this is a yes. What about the fan blades on this fan?
No.
No. Why? It's actually reflection. So this is a no, and you might want to write yourself a note that the blades, yeah, the blades were reflected. And you can really see that as you look at just the shape of the blade here and the shape of the blade there. Oh, I guess the cord does give it away. I suppose. I don't know if they did that on purpose, maybe. And then what about the wheel? Is this a rotation or not?
Yeah.
It's kind of hard to tell because everything's really alike. What's different? What's the one thing on this wheel that's different that you can follow with your eyes? You see that little dot there?
The screws are also filled.
You could look at the screws, but sometimes it's a little hard to determine whether it's a reflection or rotation. But if you look at that point versus that point, it could not have been reflected, right? And so what happened was we went from here to here, which is our counterclockwise rotation of how many degrees? 180 degrees. So this is, yes, 180 degree rotation counterclockwise. And really 180 degrees, oftentimes they won't say whether it's clockwise or counterclockwise because it doesn't matter, it's the same place. All right, so let's look at key concept. And you can see above here that rotations preserve distance, angle, and orientation of the figures. So that's why it is a rigid motion. It doesn't change the size or the shape of the figure. So it is the third rigid motion that we have looked at. And this is saying the rotation of x degrees, so however many degrees, about point Q. Q is called that center of rotation. Thank you. Sam, grab some notes over there. And you'll need a protractor and your compass. Notes right here. Yeah, it does not. Is that no? I don't know where the notes went.
You got a protractor.
Oh, here they are. Okay, so all we're doing is taking a figure here. Well, this is the original figure here. We are rotating it about a particular point, so many degrees. Now this one happens to be rotated counterclockwise, right? Because we're going to the left, and it's going a certain amount of degrees. Every single, now they happen to choose point V. So from point V to V prime is going to be x degrees. And that's distance from V prime to Q and from V to Q, those are going to be equal as well. So those are the things that you're looking at doing. And then in addition to that, if I'm looking at U, and let's go ahead and just draw this in here, choose a different color. If I drew a line from Q to U prime and from Q to U, I know it's not a very straight line, but this angle here also is going to be x degrees. And the length from Q to U prime and from Q to U are also equal. And so that will be the same with all 3 points if you did that. Now it looks like I'm drawing the same line from here to here, but it's really not. It's really going from here to here. So it's a different line than this red dotted one. It's just hard when I don't have the use of a ruler, but you do. You have a straight edge, right? All right, so let's actually look at rotations. So here's problem 1, and we're gonna stop here today at problem 1, and this is the only type of rotation you're gonna do on your homework. Tomorrow we will or Monday we will rotate in the coordinate grid. So I thought I'd get you to do this first, and then we'd work into the coordinate grid, little bitty baby steps at a time. So the question says, what is the image of triangle LOB for a 50-degree rotation about B? The rotation is assumed to be counterclockwise. That's a terrible counter. So the rotation is assumed to be counterclockwise, unless they say something different. And it's rotating about itself, point B. So that's an actual point on the figure itself. So take your, now I'm not going to have the ability to do this, but what I want you to do is I want you to take, well, we'll go ahead and look at the questions here. So question 4 says the image of point B is itself, mostly because we're rotating about point B. So our rotated image is going to touch at point B. So B prime is exactly the same as point B. So that one we don't have to rotate. The image of triangle LOB will be triangle L prime, O prime, and you could just say B. If you said B prime, I wouldn't mark you off for it, but B and B prime are the same. So I need to blank the triangle blank around point blank. Well, what point are we, well, first of all, what transformation are we doing? Okay, so I need to rotate triangle LOB. How many degrees? 50 degrees around point B. And by the way, I didn't note the difference in notation. Go back above here and look at this notation right here. How does the notation change right here? We have a little baby r, right? So this notation here is saying that you have a rotation. So when you have a lowercase r, it means a rotation. Uppercase r means a reflection. So lowercase r means a rotation of x degrees about point Q in this case. And it gives you, the result is the rotated figure. So get familiar with this notation right here because that's another change in notation. And so if we were to write a notation for this figure based upon what we've just said here, it would be little r. So we're rotating how many degrees? 50 degrees. So it kind of looks like an ordered pair. About what point? B. So capital B and parentheses. And that's going to equal triangle L prime, O prime, and B. So we're going to begin, I personally would begin by drawing side. Let's go ahead and, it'll be easier if we take this side and rotate it 50 degrees. So I'm going to begin by drawing side L prime B. Then we're going to draw O prime B, side O prime B. So you take your compass, and then I'm going to show you later off of this video. I'm going to show you with my compass. But you take your compass, and I want you to measure from, this is your, so you're going to do your compass upside down. Or you can turn your paper. I can't turn this, but you can turn your paper so that this, so your triangle's upside down. So turn your paper 180 degrees. Then you're going to take from point B, you're going to put it at the center of your compass, and you're going to measure a 50-degree angle from here to here. So from here to here, you're going to measure a 50-degree angle. You're upside down. Your, what did I say, compass? Your protractor. Should be your protractor. Sorry. My bad. So take your protractor and measure a 50-degree angle. And then we're going to use our compass for congruent sides. So your 50-degree angle is going to go, you know, like somewhere along this entire line here. You can make the line bigger, and we'll find the congruent sides in a minute. So just create that 50-degree angle. And then you're going to go put it on B, and you're going to go inside for 50 degrees and put a point and then connect it. Yeah. Uh-huh. I'll show you here in a minute for real, but you try to do it on your own. Because I can't show a compass up here. Or a protractor.
I asked the line.
Alright, so I will have a separate video that shows what we just did, but I'm going to go ahead and finish marking this. So we're going to assume that O you mark this with your compass, and that this was L prime. And then we took this right here and made another 50-degree angle. And so let's say that that was from here to here, was 50 degrees. And then we marked with our compass the length of O. So that's O prime. And then at this point, we just drew, and I'm going to darken it, from here to here to here was our rotated figure. I'm free drawing this totally, but we just did it with a compass and a protractor, right? What? All right, so we're going to circle the tools that we just used. What tools that we just used to draw L prime, O prime, B prime? What's that one? Compass and a protractor. A ruler, we don't really need one because you've got a straight edge on your protractor, or even on the compass that we were using, right? Okay, so write true or false. This is the last that we're going to do today. To draw triangle L prime, O prime, B, I will rotate the pre-image clockwise. Is that what direction we rotated it? Look above here. What direction did we go? We went from here to here. Isn't that counterclockwise? So this is false. We went counterclockwise. So the assumption is that you rotate counterclockwise unless otherwise directed to do so. The next one, the sides of the image must be congruent to the sides of the pre-image. True or false? Congruent to the pre-image. That is true. I need to use the compass and protractor to draw only two sides of the image. True or false? How many sides did we draw? Two. Because we essentially did, so this is true, we essentially did SAS, didn't we? We used the angle, and then we drew the two sides that included that angle. And then finally, each angle in triangle L prime, O prime, B is 50 degrees greater than each angle in triangle LOB. 50 degrees greater. Is that true or false? Are they exactly equal to 50-degree rotation, or are they 50 degrees greater? What are the angle measures in the image and the pre-image? Are they equal or different? They're equal because it's rigid motion. So is this true or false? This is false. And thus endeth the lesson for today. All right, so today you're going to rotate in the coordinate plane rather than just on a blank piece of paper using a compass and your protractor. So you're going to use your algebra. You need to memorize these 4 rules. I will not give them to you. You must know them. And so all this is saying is, if you are rotating 90 degrees, so you're taking a point here, and you're rotating at 90 degrees, that's to the left, counterclockwise, your X and your Y are going to switch. And in addition to that, your Y is going to change signs. So the original point was 2, 3. So notice that the X and the Y switched, 3, 2. But in addition to that, the Y changed signs. It changed its sign to a negative. If it were a negative, it would have changed to a positive. However, if you're going to rotate 270 degrees, which normally if this is 0, 270 would go all the way around to here. So it's 3/4 of the way around the circle. So if I'm going to rotate this point here, I'm going to go all the way around here to here. So notice that your X and your Y still switch places, but this time it's your Y that changes, or I'm sorry, your X that changes signs. So we had 2, 3. We still switch it to 3, 2, but this time the X coordinate becomes a -2. Change signs. For a 180-degree turn, which just means you're going from one end, if you were to draw a straight line through the rotated points, you're going from one end to the other end of that line. It's halfway around the circle. And notice that you don't switch the X and the Y for 180 degrees. You just keep them the same, but you do switch both of their signs. So both the X and the Y switch signs. So we went from a 2, 3. still remained a 2, 3, but both the 2 and the 3 change signs to negatives. If you have a 360 degree turn, it means that your point is starting and ending at the same place, so nothing changes. So you can make a complete circle around here to get back to that point. So let's look at example 2. So look at number 7. Circle the correct ordered pair you use to find a rotation of 270 degrees. So which one is that? The first, second, third, or fourth one? The third? It's the fourth. Look at what's above. We're doing 270 degree turn about the origin. And so there's that rotation again. Look at the notation. It's a little r, so I just drew a line over the little r, but it's a little r, meaning rotation, 270 degrees about O, the origin. So always assume that O is your origin. They tend not to let letters in the coordinate grid be O, 0. So use the rule you circled in example 7, fill in the blanks to find the coordinates for each vertex of the image and graph. So they went ahead and they gave you, for f prime, they gave you the original image, which was -3, 2. But according to this rule, we're going to switch the x and the y and change the sign of the x. So if I switch the x and the y, I get 2 and a -3. But what happens to the x value? The x value right here, what happens to that? It switches to a +3, so it becomes a 2, +3. And if we were to plot that over here, we would end up here for f prime. Which makes sense, and I'm going to erase this part. That means that I went 270 degrees from here to here. And that makes sense. It's 3/4 of the way around the circle. So I'm going to erase that and keep just the point. All right, so then let's look at G prime. So G prime, we've got to find the ordered pair for G. So what's the original ordered pair for G? -3, -1. And so you're going to switch your x and your y, and you're going to change the sign of the x. So what do you get? -1, +3. And so you're going to plot that, -1, +3. Puts it right here, G prime. Now, our f and g, well, f and g here are side by side, but notice how they're vertical to each other here. So it makes sense that they would form that straight line. And so I'm going to connect those two. You're connecting with a straight edge, I can't. So then let's find H prime. So what's the original ordered pair for H prime? -1, -1, bless you. And then what is the translated point? The rotated point. So the y value stays the same, -1, but the x value changes signs to +1. So your y value is coming first this time. And so you're going to plot a -1, +1, which would be right here. And that is your H prime. So connect those. And then our last point, I prime. So original I, ordered pair is what? It is 0, 1, and that's a hard one because a lot of times you guys tell me it's 1, 0. So it's 0, 1. And so when you switch it, what happens? It becomes a 1, and can you change the sign of 0? Nope. So it becomes 1, 0, and that's on the x-axis right here. And so this is I prime. So there's your rotated figure. It's a lot easier to do it in the coordinate grid without your protractor, right? And your compass. Okay. So you're going to do several of those types of problems today on your homework. So then look at problem 3. In the diagram, WXYZ is a parallelogram. We know a lot of stuff about parallelograms. Opposite sides are congruent. Opposite sides are parallel. Opposite angles are what? Congruent. What about consecutive angles? Supplementary. What about the diagonals? Are the diagonals congruent in a parallelogram? All parallelograms? Nope. What are the diagonals, though? What do they do? They're not perpendicular. They bisect each other, right? So, you know, all kinds of stuff. And they do say that T is the midpoint of the diagonals. So that's this point right here. See if I can get right in the center. So that's T. Can you use the properties of rotations to prove that WXYZ is a rhombus? What would we need to prove for it to be a rhombus? What's the difference between a parallelogram and a rhombus? Are all rhombi parallelograms? Yes, they are. What makes them a special parallelogram? Nobody can answer that, seriously. We're going to be in trouble. How is a rhombus and a square alike? All sides are what? Nope, not all sides. Opposite sides are parallel, but that's because it's a parallelogram. Jessica? All sides are equal. So if it's a rhombus, you have to prove that all sides are equal. So fill in the blanks or circle the word to complete each sentence. A rhombus is we already answered that. What is it? Parallelogram. It is not a rectangle with 4 congruent sides. To prove that WXYZ is a rhombus, I need to show that WX is congruent to XY is congruent to YZ is congruent to ZW. I have to show that all 4 sides are equal to each other. Since the side lengths of WX, XY, YZ, and ZW are known or unknown, do we know their side lengths? Nope, they are unknown. You can or cannot use a rotation to prove. Cannot. What the rotation will do is it's a rigid motion, so it'll keep the same size and same shape, but it's not going to, you can't prove that it's a rhombus from there. You can only prove that the size and the shape did not change. All right, so lesson check. Let's see if you understood what we just did. So point P is your XY point, and it's rotated about the origin by 135 degrees, and then by 45 degrees. What are the coordinates of the image of point P? And explain. So they're going to walk you through that. So what is 135 plus 45? It's 180 degrees. So you have a rotation rule for 180 degrees. So I want you to look at that rule, match it there, and then decide the rest of it. I'm going to silently do it up here without you seeing. Point P on there. Are we missing point P?
Yeah.
We're totally missing point P. Okay, so since we're missing point P, put point P, because you see a little blank spot there, right? There's nothing that told us what point P was, right? I'm not missing it. Okay, so we're going to let point P be, let it be 2, no, let it be 3, 2. So point P is 3, 2. So I want you to discuss with those around you what you got. Okay. So here are your answers. Shh. Here are your answers. So up here, your 90 degrees rotation is the negative y, positive x. Your 180 degree rotation, which is what we just did, is negative x, negative y. So the x and the y stay in the same spot. You just change their signs. And then the 270 is what we were just working with, is y negative x. And then 360 stays identical the same, x, y. So for our purposes here, we're using the rule lowercase r, 180 degrees about the origin, and we're going to keep the x and y in the same spot but change signs. So we let p be 3, 2. Keeping the x and y in the same spot but changing signs gives us negative 3, negative 2. And you can kind of check that by taking a line and running it through the origin and through your other point. Doesn't it make a straight line? And so this angle of rotation from here to here is 180 degrees. So as long as you take your point and run a line from the point to the origin to your prime point, for a 180 degree turn it should be a straight line. If it's not, then we did something wrong. And then I just explained that essentially you keep the x and y values in the same position, but you change your signs. So are there any issues, problems, or concerns with that? That's all you're going to do today. So you might want to put these on a little note card and memorize them. Yep.
So in P, if one of these numbers is negative, we change that to positive.
Yep, so if we did, let's go ahead and put in here Q. And let's see if I can erase this. Yep. So let me get that out of the way. And I'm going to erase this as well. So let's say that Q is negative 2, positive 3. What would Q prime be? Q prime would be positive 2 but a negative 3, right? So let's plot, because all you're doing is you're keeping your x and your y values in the same position, you're just changing their signs. So let's go ahead and plot Q. So Q would be negative 2, positive 3, so Q would be right here. What quadrant should Q prime end up in? So it should end up in quadrant 4. And so we get 2, negative 3. Oh, are you interviewing? Okay, there you go. Does that make sense? And then if I drew a line through the origin to that point, it should make a straight line, which it does. Any other issues, problems, or concerns? Okay.